Hello, once again welcome to my channel. Today we are going to discuss about Hall effect transducer. So before discussing about Hall effect transducer, we must know what is Hall effect. So when a current conducting material is placed in a transverse magnetic field, when a current conducting material, so this is a current conducting material, is placed in a transverse magnetic field, then the difference of potential produced between the opposite edge of the conductor. So if a current carrying conductor is placed in a transverse magnetic field, then a difference of voltage is produced at the opposite edge of the conductor. So this effect is known as Hall effect. So as seen in the figure, so this is a current carrying conductor and it is placed in a transverse magnetic field. Then a difference of potential is produced between the opposite edge of this conductor, as this labeled as EH. So this effect is called Hall effect. And the magnitude of voltage depends upon the current, the strength of the magnetic field, and the property of the conductor. So the developed voltage or the magnitude of this voltage is depends upon what are three factors are there, that is current, then second the strength of the magnetic field, that is this magnetic field, and third the property of the conductor. So this is the basic principle behind the Hall effect transducer, or what is Hall effect. So again, now let us again consider, the current pass through edge 1 and 2. There are two edges there, edge 1 and 2. The current pass through the conductor, edge 1 and 2. The output leads are connected, the edge 3 and 4. This is the output edge. So the edge 3 and 4 are at same potential when there is no transverse magnetic field through the conductor. So when a transverse magnetic field passing through the conductor, the output voltage appear across the output lead, that is called EH. And this output voltage is proportional to the current and field strength. So this output voltage is proportional to the current and the magnetic field B. So this output voltage is written as EH is equal to KH into I into B divided by T, where KH is the Hall effect constant and I is the current in the circuit, and B is the flux density, and T is the thickness of the conductor. So this is how we can calculate the output voltage developed here. So it is depending upon the magnetic field, depending upon the current, and the thickness of the conductor. This is the T is the thickness of the conductor. So by varying these three quantities, we can design different type of transducer using this Hall effect. The current and magnetic field strength both can be measured with the help of this help of the output voltage. So the Hall effect EMF is very small in conductor, because of which it is difficult to measure. But in semiconductors like germanium produce a large EMF which is easily measured by moving coil instrument. So we mainly use semiconductor materials for measuring Hall effect for for measuring the Hall effect. So applications. First application is magnetic to electric transducer. This transducer uses a magnetic to electric transducer, that is convert magnetic field into magnetic to electrical signal. So a semiconductor plate is inserted into the magnetic field to be measured. And the magnetic line of force are perpendicular to the semiconductor plate. The transducer gives out the output voltage which is proportional to the magnetic field density. Also, the element gives out a continuous electrical signal in direct response to the magnetic field strength. So, by using this transducer, we can measure the magnetic field density B. So, what is the magnetic field? We can find out the magnetic field by measuring the output voltage, as say the earlier slides. So, this is how the magnetic field is converted to electrical signal. And the second, measurement of displacement. The Hall effect element measures the displacement of structural element. For example, consider the ferromagnetic structure which has a permanent magnet as in the figure here. So the Hall effect transducer placed between the poles of permanent magnet as in the figure. The magnetic field strength across the Hall effect element changed by changing the position of ferromagnetic field by we can change the position of this ferromagnetic field. So we can find the field strength across the Hall effect element. So due to change in magnetic field strength, the Hall effect EMF changes which can be calibrated with the displacement of this ferromagnetic plate. So by we can calculate the displacement like this. So the output voltage of Hall effect transducer is proportional to the field strength, the gap, which is a function of position of ferromagnetic plate from the structure. So this is how we can measure the displacement. And the next is measurement of current. So the Hall effect transducer is also used for measuring current without any physical connection between the conductor circuit and the meter. So the AC or DC is applied across a conductor for developing magnetic field. The strength of this magnetic field is directly proportional to the applied current. So by passing AC or DC, and the strength of this magnetic field is directly proportional to the applied current. And the magnetic field develops the EMF across the strips, and this EMF depends upon the strength of the conductor. Thus, we can calculate the strength of the measure the current in a conductor. The next is measurement of power. So it is used to measure the power of a conductor. So current is applied across the conductor, which develop a magnetic field, and the intensity of the field depends upon the depends upon the current. So magnetic field induce the voltage across this strip. The output voltage of the multiplier is proportional to the power of the transducer. So these are some applications of Hall effect in transducers. So this, what are that? Then we can see the advantage of this transducers, Hall effect transducers. First one is a true solid state. It has a long life because Hall effect transducers are not affected by ambient conditions such as rain, dust, humidity, vibration, etc. So it has long life. It has high speed operation. It operates with stationary input. There is no wear and tear since moving parts are absent. It can be operated over both temperature range from minus 40 degrees centigrade to 150 degrees centigrade. It has a highly repeatable operation. So these are the advantages. Then disadvantages, it is not capable of measuring current flow at distance greater than 10 centimeter. For more long distance, we cannot be use these Hall effect transducers. Since Hall effect utilize magnetic field for measurement, stray magnetic field may cause the incorrect reading. Stray magnetic means earth magnetic field may affect the reading. So these are the advantages and disadvantages of Hall effect transducer. Then we see the applications. It is used as a magnetic or an electric transducer to measure, can be used as a magnetic or electric transducer to measure the magnetic field. It is used for measurement of displacement. It is used for the measurement of AC or DC current. It is used for measurement of power. Open or closed detection of laptop flip screen. Variable speed devices used in flow meters, used in encoder switches, used in motor control protection indicators, used in rotary encoders. So these are the applications of Hall effect transducer. So today we discuss what is Hall effect and the application of Hall effect transducers, different type of application, and also we discuss the advantage, disadvantage, and applications. So thank you for listening to me.